Okay, so just like I mentioned, those of you who took my advice earlier and decided, you know what, Mr. Zukin told us factoring was really important, we're going to need it later, and you took that advice, and you're like, and you ran with it, and you're really good at factoring, and you're confident in your factoring abilities, this section's not going to be too bad. Those of you who chose not to take my advice and are shaky with factoring, you're going to find this section a little more challenging, okay? The first thing we're going to start off with is a new method of factoring that we have never learned before. I don't think you would have ever learned this in another course either. And that method is either a sum or a difference of cubes. In the past, we've talked about difference of squares, but we couldn't ever factor a sum of squares, which is still true. We can, however, factor things that are called sum of cubes or difference of cubes. But before we get to that, we have to make sure we know what cubes are, because you don't probably know too many of your perfect cubes. At this point now, I think you've identified a lot of numbers that are perfect squares and have probably gotten kind of good at that, but we need to talk about the sum and difference of cubes first. It is true, unlike difference of squares, we can factor both. There's a formula for the sum of cubes, there's a formula for the difference of cubes, and we'll go through those. But first, we're going to identify some of the cubes, all right? So when we make a list, I'm going to eventually give you the list, but let's create a list, all right? So if I was going to come up with the first perfect cube, what would you say it is? 1. How did you come up with that? Because the first perfect cube is 1, because this is 1 cubed. Okay, what is the next perfect cube? 8. How did you get that? 2 cubed. What is the next perfect cube? 27. Okay, you get the gist here? Those are all perfect cubes. All right? And some of the perfect cubes that you need to kind of get used to knowing, those are some of them. Of course, are the rest of them. These over here are the perfect cubes. This list right there. Okay. Those are numbers you should probably start becoming familiar with and identifying as special when you see them. Okay. Now, there's one number on here that's sort of extra special. Well, 2, I guess, if you really count it. Any ideas what 2 numbers on here are sort of extra special?
64.
Why?
Because it's also a square.
Okay, so 64 is not only a perfect cube, but it is a perfect square. Anything else? 1,000? Why is 1,000 extra special? Is it a perfect square? Yeah, 1,000 is not a perfect square. 1. 0, we don't worry about 0, right? And 1. Okay, so there are more numbers that are perfect squares and perfect cubes. But I don't know, I just find that interesting. So whenever you see a 64, you should know something's up. It might be difference of squares, it might be some are difference of cubes, but I know I need to think there's something going on there, okay? I would say you should know probably up to 125, maybe 216. You might memorize some of those, okay? You might get to the place where you start seeing some of those numbers and thinking, these are kind of important. Something's up with it. Maybe I should investigate it further. Okay? So those are your perfect cubes. Now I'm going to give you the formula. I should find out what page this is on. Let me do that real quick. Page 797 is where you can find those formulas. So whether you want to write them down, take a picture of the screen, screenshot from your book, I don't care, but get those formulas into your book. And then I'm going to talk to you about kind of the way I like to think through it. Yeah. If you're choosing to write it down, be very careful with your signs. You want to make sure you have the right signs in the right places. So one thing that's important to recognize here is when we're factoring a sum or difference of cubes, the problem is going to look like this. Okay, so that's the problem. You'll have a perfect cube plus another perfect cube, or you'll have a perfect cube minus another perfect cube. It won't look like that in terms of, well, won't necessarily look like that. It won't necessarily have a third power. All right, so this is the key. The problem will look like this. How you factor it goes like this. All right, so what's important is our first step after we've identified that we either have a sum of cubes or a difference of cubes is we need to know what A and B are. And so the way that we do that, we take that first term, we take the cube root of that, and that will tell me A. Then I take the cube root of this, because cube rooting and cubing cancel each other out. Just like square rooting and squaring cancel each other out. Then once I have A and B, I can just plug them into the formula. The fronts are A squared of the trinomial. The back is B squared of the trinomial. The middle is A and B multiplied together. One case is minus, one case is plus. And I can tell you that that's always the opposite sign. So since this is a sum of cubes, the binomial is also a sum. But the first sign that you write down in the trinomial is minus. It's opposite that. For a difference of cubes, the binomial is subtraction just like the problem, but then the next sign after that is opposite. And then this last term is always plus. So it always kind of goes in that form. And we're going to go through an example together. But the key is you have to know the form. You have to memorize this. And however, in your mind, you have to get it straight, figure out a way. Okay, I'll talk to it like how I do it. And if that's helpful to you, great. But you do need to know this, and you will need to know this on your test. Okay? And every year, I get kids that try to factor this, and they factor it wrong. Because, again, you didn't take my advice. I'm literally telling you a question on your test is going to be like this, at least one. Okay? So you just got to be careful. All right. Now, there's two types of problems that you may work through. See, because this is just straight up factoring. And back in chapter 4, we talked about factoring, and we talked about solving by factoring. All right, so we got to make sure that we keep that straight. So we're going to start with a factoring problem, and then we're going to turn it into a solving by factoring problem. So here's the problem we want to look at. Okay, factor each polynomial. If the polynomial cannot be factored right prime. Well, those are just directions that I stole from the book. This is going to be factorable. And the problem that we're going to focus on here is 16x to the fourth plus 54x. So although we have a new method of factoring, and we're probably going to use that, right? We still have to remember all the original rules of factoring, because anytime you have a problem that may need factoring, you have to do what? What do you have to check for first? Greatest common factor. You always have to do that. Skip a slide? What happened? Nope. Always have to do that. Okay? And so in this case, the greatest common factor is 2x. Just skipped a step. Okay. So I have a 2 in common. I have an x in common, so I just pull that out. Basically divide everything by 2x. Okay? In any factoring type of situation, you always want to take the greatest common factor out. Now, we've talked about this a little bit. Anything interesting about these two numbers? They are perfect cubes. Okay? What's left inside is a sum of cubes. And we're going to go through how to factor that. And here's the way that I like to do it, okay? And so I recommend that you do it this way too. In order to use this formula, I need to know what A is and I need to know what B is, okay? And the way that we do that is, as I mentioned before, is we just take the cube root. So this is A to the third and this is B to the third. So in order to get the 3 off the A and off the B, I just take the cube root of both. So what I'm going to do is start with my setup like this. A is the cube root of A to the third. So just in case we're unfamiliar with that notation, it's the same radical symbol, but we write a little 3 here. That's called the index. We'll talk a lot more about that later on in chapter 6. And then same thing, we're going to take the cube root of 27. We don't have to worry about this plus or minus here because the formula takes in account for the plus or the minus. So we really just have to worry about this number and this number. So when this becomes a minus type problem, you don't have to say cube root of minus 27. Just 27. The formula takes care of the fact that it's a difference when we get to a problem like that. Now, what is the cube root of 8x to the third? So the cube root of 8 is 2. What is the cube root of x to the third? X, okay? And we'll get into this more again in chapter 6. But in this case, the cube root and cubing cancel each other. Another thing to think about, I'm just going to throw this out there now as a little appetizer for later. You can divide the power by the index. So if this was like 8x to the 6th, then the cube root of x to the 6th is x squared. 6 divided by 3. Okay, and like I said, we'll get into that much more later. And what is the cube root of 27? 3. All right, so this is an important starting place. Once I know A is 2x and I know B is 3, the rest is just substituting it into the formula. And now we've got I'm going to pretend the formula is not sitting up there and I'm going to explain to you how I think through it. All right. Since this is plus, all the signs are plus except for the first sign that we write in the trinomial. Okay? And so if we look at this formula, all the signs are plus except for this first term. Okay? If it was a difference, there's only one minus. All the rest are plus. So you just have to know, where does the minus go? There's only ever going to be one minus that goes in the formula. It's either going to go in front of the middle term of the trinomial, or it's going to go in the binomial. You just have to figure out a way to keep that straight. Okay? All right. So here's how we're going to write this out. Okay? So anywhere there's an A, so we're using this formula up here. Anywhere there's an A, we're putting a 2x. Anywhere there's a B, we're putting a 3. So when we think about what we did in 5.3, when we were evaluating expressions and we were plugging numbers into spots, that's just practicing using a formula, right? So in 5.3, when we had a variable term that we had to plug into an equation, we're doing that again here in this formula. In 5.3, when we had just a number that was being inserted into equation, we're doing that here, okay? So that's what that was sort of setting us up for. Now, the other thing to keep in mind is we're going to do that just for the sum of cubes. This 2x is still going to hang around. We've talked about this when we were factoring earlier. Once you take your greatest common factor out, it just kind of hangs around like that friend you can't get rid of, okay? It's the same kind of thing. We talked about that before. So here's how it's going to look. Actually, go ahead and try to fill it out. Go ahead and try and do that. And let's see how you do. And just a little reminder, the only part that we're filling out is this. This was the problem. We're only using this. Okay, so what happens here? First off, the 2x has to hang around. Okay, the 2x still has to be here. Okay, shh. This 2x still has to be here. I realize there's another 2x. And I'm going to color code it so we keep it straight. Okay, the things that are black were already there. The things that will be red and blue weren't, okay? And you need to be careful. So since this is a sum of cubes, there's going to be a 2x plus 3, a plus b. When you go to square stuff, you have to be careful because you have to square the whole thing. So here's the 7. Okay, so this is the 2x that was still there. That's why it's still black. Now the parentheses are always going to be there from the formula. The signs are always going to be there from the formula. Why did I make it a minus there? I didn't. Hold please. Hold please. Hold please. I will fix it.
Okay.
I messed it up. That should be minus. That should be plus. Why is that not letting me erase? Hold please. And that should be minus. That's better. Sorry. In the end, this all has to be equivalent to my beginning problem. So if I leave the 2x off, all I'm going to have is 8x cubed plus 27. I'm not going to have my original expression. So that's why it just has to hang around. Okay, since this is sum, this is plus, this one is minus. Okay, notice here that I put the 2x, which is a, in parentheses. I did that because a lot of times what kids will do is just write 2x squared, and with the 2 over the x and not square the 2, you have to be careful there. And then here I've got 2x times 3, so that's a and b, and then this is b squared. I didn't put parentheses here because it's just 3. Okay. Now, I'm just going to warn you as we move on from slide to slide, I'm going to have to fix the signs because I messed that part up, but it's fine. Okay? Questions about where this came from? How many had that? That's good. Okay? So my next move, and I think I moved this stuff out of the way since I'm running out of room down here, is just simplifying. Let's change the signs back to what they're supposed to be. Okay? Now it's completely factored. It's completely factored. Okay? I can't factor anymore. Here's the thing that I will tell you, and this I'm going to keep saying this. This trinomial here will never be able to be factored. Okay? That trinomial will never be able to be factored. And the reason why is if we look at this formula, each of these trinomials, they look a lot like binomial squareds, right? What's missing? What's missing from both of these that makes it not a binomial square? The 2. There's a 2 in the middle, right? Okay, so that's why I know that they're not going to be factorable. All right. Now, this is part of what you're going to do is factoring. The other part is solve by factoring, meaning I have an equation. So what I'm going to do is turn this thing into an equation, and again, I'm going to have to go, because I wrote it all out ahead of time, and the signs are all going to be off, so I'm going to have to fix all the signs, so sorry. But hopefully you can look past my mistake, not judge me too harshly. We'll fix it, okay? So let's go through one of those so that you have an understanding of what it could look like, okay? It could look like this. And actually, I'll take it a step further. The original problem would have been 16x to the 4th minus 54x equals 0. So this is going to be the problem, and it'll say solve by factoring. Now, we already did all the work to factor it. But understand that your original problem will look like this. It was plus, wasn't it? Okay. So all that work that we just did on the previous slide.
At least that could never be factored.
This could never be factored?
No, like or
No, just this part can't be factored.
oh, so you just leave it. Like what if you guys have just leave it?
No.
Okay.
So hold on. Since you mentioned that, okay, this trinomial is what type of expression?
Quadratic.
It is quadratic. We know lots of ways to solve quadratics, even when it's not factorable.
Oh, so you can just like solve it like you just can't factor it.
We're getting there. We're going to do that. Okay? All right. So this would be the original problem. The work we do to solve it ends up being this, because we're going to be able to factor it. And we're going to look at some other ways in this chapter to solve polynomial equations. But for today, they're going to be factorable. Okay? So, really what I have here, and I have to change all my signs again, so just relax. So this is going to be plus, this is going to be plus, this is going to be minus 6x, this one up here is, right there. Okay, so just like before, we have these factors. I set each of the factors equal to 0 and solve. So I can get a solution out of this pretty easily. I can get a solution out of this pretty easily. This is another question because, as I've been talking about, this is never going to be factorable. So we have to figure out what to do with that. Okay, so what's the solution going to give me from here? 0. What's it's going to give me here? Negative 3/2, right? Okay, subtract the 3, divide by 2. All right. So again, I got to go back and change all my signs because that's supposed to be plus. This is supposed to be minus. I'll have this fixed by next class, okay? And so again, ideal world, we're going to try to factor this. But as I've been talking about, we know that's not going to be factorable. Okay, that trinomial will never be factorable. And I think it's important that you write that down. I've been talking about it. But that trinomial in the sum or difference of cubes formula will never be factorable. So we're going to have to solve another way. So what's the next best way? If you can't factor a quadratic, what's the next best way to solve it? What is our method going to have to be? Quadratic formula, okay? That's what's going to happen. You're going to have to use the quadratic formula. Now, I'm not going to go through and change the numbers on here yet because when we get to the problem and actually solving it using the quadratic formula, then I'll get the numbers right, okay?
What's wrong?
It's all that because I wrote it as a, this is supposed to be a plus, that's supposed to be a plus. That makes that minus. So there we go. All right. So what we're going to have to do is the quadratic formula. Are all my signs right now? I think they are. They are. All right. So let's just do that. All right. If you want to try it, go for it. I'm going to work it out on the screen because I know that the next few slides I'll have the signs wrong. So whatever, I'll just write it out. Okay. So go ahead and give that a shot, and then we'll see what the answers are. Actually, let me get rid of this. So we're going to use the quadratic. All right, let's break this down. So, of course, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I have, since b is already negative, negative b is positive, plus or minus the square root of negative 6 squared, that's b squared, minus 4 times a times c all over 2a. That is my setup. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have to simplify that all down now. And then get some answers out of that. All right. So I'm going to have 6 plus or minus the square root of, and I already know this because I did it ahead of time, negative 108 over 8. It's 36 minus 144 on the inside. Okay, be careful of your signs on the inside there too. Okay? Now, we have a negative under a radical. That's a problem, all right? So I'm going to pull the I out. And then I need to figure out what's a perfect square that goes into 108. 9? Okay, so 108 divided by 9 is 12, right? Is there a perfect square that goes into 12? 4. So if a 9 goes into it and a 4 goes into it, what's a perfect square that actually goes, the biggest perfect square that goes into 108? 36. Okay, so here's what I've got. 6 plus or minus, now I'm going to just pull the I out, 36 times 3 over 8. Okay? I know that's all crammed in there really good. What is the square root of 36? 6. So I'm just going to move this way. So I've got 6 plus or minus 6i root 3, the 3 stays in, all over 8. Now I can reduce this, right? And we've talked about this in 5.1. We talked about this in chapter 4. I can cancel, whoa. I can reduce here and also here. But you have to do it in both places. You can't just do one. You can't just do this 6 over 8 without doing that one. It's just like what we talked about in 5.1. That denominator is under both parts. Okay, so what goes into all of that? 2. 2 goes into all of those. So if I just reduce them down by 2, okay, I get 3 plus or minus 3i root 3 over 4. And that's as far as I can go. So here's where I land. 1 solution, 2 solution, 3 and 4 solutions. Because 3 plus 3i root 3 over 4 is 1. 3 minus 3i root 4 over 4. And if you think back to our original equation, I'm just going to give you another preview of something. What's the degree of this equation? 1, 2, 3, 4. You should get the same number of solutions as you have the degree. Okay, so it's one thing to factor. That's what we did at first. If your problems in your homework say factor these, then factor. If it says solve by factoring, then you got to do this. This kind of thing is going to be on your test, 100%. Okay, so make sure you know what you're doing there. That's about the hardest stuff. Now, we need to get into another method of factoring. Some of you already know this one because I watched you do it during when you were solving factoring trinomials, okay? So for those of you who already know how to do this, great. Maybe you watched one of the videos on this when we were doing factoring, fine. We're going to expand on that a little bit. That method is called factoring by grouping. Essentially what we do with factoring by grouping is we're going to create 2 problems within them. Okay? Now, I'm going to give you the steps, break them down, and that way it's kind of clear what you're supposed to do. We'll go through an example, and then we'll have one other example at the end, another factoring method that's really not too different than what we've done before, but it's a little bit different. Okay, so step number 1 is you're going to use this method when there's 4 or more terms. It's the only time. If there are less than 4 terms, you don't need to use this method. 4 or more terms is when we use grouping. Okay. So step number 1, once we've identified that there's 4 or more terms, you're going to group the first half of the terms together and then factor it like it's its own problem. So there's where we've created a subproblem. And I think you can use your inferential skills to come up with what number 2 is going to be. What is number 2 going to say? What's the second step going to say? Same thing, but what? The second half, yeah. Copy, paste, change first to second. Okay. Then you're going to group the second half. Now I say half. Okay. A lot of the times there will be an even number of terms, so you'll have 3 and 3, or 2 and 2, or 4 and 4. But sometimes there's going to be an odd number of terms, and you might have to put 2 of them together and 3 of them together. Okay. I don't think that's going to happen in your homework. But it is possible in the world of mathematics that you have to do things like that. Okay? Because you could have a sum of cubes, and then you could have a trinomial that both could be factored. Now here's where it gets interesting. Because there's something that is supposed to happen if this is going to work right. After you factor the first half and after you factor the second half, there should be something in common between the two halves. Okay? And that's what this is saying. There should be a group in common between the two halves after you factored each half independently. If that doesn't happen, you've either done it wrong, it's not factorable, or you need to rearrange the order of the problems. Of the terms. You have to rearrange the terms so that you force this to happen. And I'm going to show you how to look for that if it doesn't happen, if it doesn't work. The examples that we're going to start with are going to be set up nice for us, and then we're going to get into some ones. Then I'm going to show you how it might look different so that it wouldn't necessarily work. So here's the example that I want us to look at. Okay. So notice here we have 6 terms. So this is a perfect example of why we would need to use grouping. So here's what this is going to look like. All right. So since I have 6 terms, I'm going to just put parentheses around the first 3, and then I'm going to put parentheses around the last 3. And we're going to treat each of those sets of parentheses like they're their own problem. So when I do this, I go, all right, I have this trinomial here. I should check for what first? Greatest common factor. Is there one? Yeah. What is it? 4. For what? 4x. Okay, I have a 4x in common. So I take the 4x out, and then I divide that, and so I'm left with 2a plus b plus c. Agree? So here's what you got to keep in mind as you're working through factoring, grouping. Okay? What should happen over here, if I do this right, I should get another 2a plus b plus c. That's what should happen. Okay? So what is the greatest common factor over here? 3y. So I just pull that out. Now I'm going to make it's positive. So I go plus 3y. When I divide everything by 3y, what do I get? Do I get 2a plus b plus c? Divide that. 2a plus b plus c. So that's good. So I have a group in common. I think I talked about this before. I have a common blob. The green blob is in common on the left half and the right half. So what I do is I treat that green blob, that set of parentheses that group like a greatest common factor. And so I factor it out. So I take a 2a plus b plus c, my green blob, I take it out of both terms. And I'm left with 4x plus 3y. Now it's factored. That's how you factor by grouping. Yeah.
So what if they're not the same?
So let's talk about that. Let's talk about a situation. And let's do it with this problem. Let me get rid of all this real quick. Anybody still writing it down before I erase it? Whoa, that is not what I wanted to do. Nor was that what I wanted to do. All right, let's just erase them. Wow, it really erased that? I didn't think you could erase those things. Interesting. No, I can't even do it. All right. On now. All right, I don't even have the problem. I didn't think I could erase a picture. Sure did. Okay. All right, tell me the problem again. 8ax 4bx plus 4cx plus 6ay plus 3by plus 3cy. Okay, that was the original problem. So notice here, all these terms are x terms. All these terms are y terms, right? So it set it up for us already. But if they would have been mixed up a little bit, like if this would have been 8ax plus 6ay plus 3cy plus 4bx plus 4cx plus 3by. Is that it? Did I get them all? Let's say the problem started off that way. Same numbers, just in a different order. Okay, and I went to group it. What's the greatest common factor there? Yeah, it's 1, right? So that doesn't get me anywhere. And then if I look at this one, I could be like, oh, shoot, that's not going to work. Or sometimes it'll even be somewhere in the middle. You can factor something out, but you factor something out over here, and then you get two different groups. If that happens, before you just abort and abandon the problem, okay, you go, man, maybe I should rearrange these in some kind of way that might seem beneficial. And one of the things that we notice here is I got an x terms, I got y terms, so maybe try putting the x terms together, rearranging it, and then trying it that way, like the problem was originally set up as. So those are things that will happen that you just kind of have to look out for. There's one other kind of problem of these that let's just look at. Okay, I will tell you that the order of this one is fine. Here's where the main difference comes in. Actually, I'll let you get that down, and then we'll talk about that difference. All right, we start off basically the same. Okay. So notice here in the middle, when I do that, now I have this minus sign. The mistake that often happens is people try to split this. Well, now you've changed the problem. That minus is attached to the 5. Okay, so you can't do that. With the plus on the last problem, if I split a plus and a number, and that number is still just implied to be positive, so I haven't done anything. So in a problem like this, what you want to do is you want to suck the minus in and add a plus there. We don't want to change the problem. Okay, so make sure that that minus sign stays attached when you throw that parenthesis in there. And of course, I need one on over here. All right, go ahead and try this one. What is the greatest common factor up here? 6x. Okay, so I pull the 6x out. I'm left with 5a minus 4b plus c. Okay? So again, my goal is to have another 5a minus 4b plus c. Okay? What is the greatest common factor here? negative y squared. Couple reasons why it's got to be negative. If you only take a positive out, then you're going to get a negative 5 plus 4 minus c. The signs are all off. And as we talked about, whenever that leading term is a negative, we've been talking about this since last semester, you should take a negative out. All right, so in this case, it's negative y squared. And again, the other thing to think about is I'm trying to get a 5a. So if I want just a 5a to be left over, I got to take the negative in the y squared out. All right, so then I divide that, and I get 5a minus 4b plus c. That flips all those signs. So now we're in good shape. And so my group that's in common is 5a minus 4b plus c, and I'm left over with a 6y, or 6x, excuse me, and a minus y squared. Now, it doesn't matter. You could have written this in the front and put this in the back. The order doesn't matter, okay? But that's what you get by grouping, all right? Questions about factoring by grouping? All right, we've got one other thing that we have to look at, and that is actually factoring trinomials that kind of look like quadratics but are not quadratics. Okay, because quadratics we know have degree 2. But we can factor other polynomials like they were quadratics with a couple little changes. Okay, so we're going to start off reviewing that. So factoring polynomial equations like they were quadratics, even though this is a quadratic, right? Degree 2. So I want you to factor this and solve. So this is solved by factoring, okay? So go ahead and do this problem. Use factoring to solve it, please. Go. All right, so again, whichever method you use, however you get there, I don't care, right? But ultimately what you should have is 2x minus 3 times the quantity 2x minus 1. That's how this factors out. And I'm not going to spend the time going through where that came from, okay? Again, that was something we've talked about. You're supposed to know how to do. If you're still struggling with that, you can come see me outside of class. And then I solve it, right? So I set each of those equal to 0. And then add the 3 divided by 2, add the 1 divided by 2, and I get my two answers. X equals 3 halves and 1 half, okay? So the same basic strategies that we used for quadratics, we're going to use for polynomial equations. Which means these polynomial equations are going to be of a higher degree than 2. Quadratics are degree 2. So these other polynomial equations in general are going to be higher than degree 2. But in a lot of cases, we can treat them like they're quadratics, even though they aren't. Okay, and I'm going to show you how to do that. Now I'm going to use a problem that has the same numbers. Okay, so just again what I've been talking about. We're basically going to do the same thing with higher degree polynomials. Okay. So this is the problem we're going to work on. It's basically the exact same problem that we just did, except the degrees are different, the powers are different. The problem that we just worked on was 4x squared minus 8x plus 3 equals 0. That was the problem we worked on the previous page. Right? The numbers are the same. The powers are off. But because it has 3 terms, here are the conditions that need to be met. It has 3 terms, it's a trinomial. Okay, maybe you didn't realize this, but in a quadratic trinomial, this is always x squared, x to the first, x to the 0. The power on this middle term is always half of this term. So since this power was 2, half of that is 1. If it falls into that form, since this power is 4, is half of 4 2? Yeah, sure. Okay, if this was a 6, this could be a 3. If this was an 8, this could be a 4. If the power of the middle term is half of the power of the first term, then you can basically just factor it like this. You just have to watch out where your powers go in your answer. Okay? What I will tell you, and think about what we did here. The variable that we used in our answer after we factored was the middle term, right? We had 2x minus 3, 2x minus 1. The x is what I'm talking about. So what's going to happen when you do these is your answers, instead of having an x in them, they're going to have an x squared in them. So we've already done the math to know what the numbers are. So here's where the change comes in, okay? So this x squared comes from this middle term. So instead of having 2x minus 3 and 2x minus 1, it's 2x squared. 2x squared, okay? And somehow you should write a note in your notes about that. Okay, one, that this middle term's power should be half of the first term's power, assuming it's in descending order. And that the middle term variable is what gets used in the binomials when I factor it. And from there, it's the same as what we've done. You just have to solve it. Do that. So I've got 2x squared minus 3 equals 0, 2x squared minus 1 equals 0. Since there's no x term here, I can just use square root property. So we're all back about chapter 4 again. Add the 3, divide by 2. Add the 1, divide by 2. The problem is I have x squared. So x squared equals 3 over 2. X squared equals 1 over 2. So how do I solve for x? How do you undo that squaring? What?
Square root.
Yeah, square root. And whenever you square root both sides, what else do you have to have? Plus or minus, okay? So we're almost there. Almost done. So I do that. I got x equals plus or minus the square root of 3 over 2 and plus or minus the square root of 1 over 2. We okay? So is that it? Are we done?
Yeah.
No. Why not? Yeah, you can't have a radical in the denominator. No radicals in denominators. Now I split them up, right? Because that's how you have to think about this. The reality is, this really means the square root of 3 over the square root of 2. The square root of 1 over the square root of 2. So I have a radical in the denominator, which you're not allowed to have. So how do I get rid of it? By square root of 2. Multiply top and bottom by the square root of 2. Okay? So this is rationalizing the denominator. We've done this before. All right. So what do I get on top here? Square root of 6. What do I get down here? 2. This is the square root of 4, right? Which is 2. All right. And then up here, this is just the square root of 2. So those are my answers now. Still, I got 4 answers like I'm supposed to. This is degree 4. I got 4 answers. Now, obviously this part here we've done before, but this part is pretty much the same. Okay? We incorporated factoring, we incorporated square root property, we incorporated rationalizing denominator, all kinds of stuff that we've done before. The only real difference here is that instead of having x's here, I have x squared. And all the rest of this is stuff that we've done before. Okay? But the trick is understanding that you can apply all of that stuff to something new. We've never solved a 4th degree polynomial before. Okay? And today we did it twice. So that's really what the new stuff is. Make sure you know your sum and difference formulas, sum and difference of cubes formulas. Okay? Make sure you know how to do grouping. Make sure you know how to factor trinomials. Okay? So there's a lot going on here. So we'll spend, you got the rest of the time to work on that, and then you'll have some homework tonight.